Hello everyone. So I'm here to teach you about the chi-squared test today. Chi-squared is a statistical test to help you figure out if what you are seeing in your experiment is statistically significant from or different from what you would expect to see. So within genetics lab, basically what we're testing is modes of inheritance. We are wondering if the trait is passed down by simple Mendelian inheritance. Is it sex-linked? Is it incomplete dominance? That sort of thing. So I've got the actual equation written out for you here. This is chi-squared itself. This guy is the summation symbol. O stands for expected. E stands for observed. So we're going to take what we observe, subtract it by what we expected to see, square that, and then divide it by the expected. We do that for every category, and then we add all of these categories together, and that gives us our chi-squared. So I'm going to pull this up for you on the FlyLab so you can get a better idea of what it's like with the software that you'll be using. Now, I have already done the matings for you guys just to kind of save time. I picked black body, just kind of arbitrarily. I knew it's Mendelian, so I used that one. And I just mated with all of the defaults. I chose 1,000 progeny for each, that sort of thing. So when you get down to all of your matings, we have this cool little bar over here where it helps you with the chi-square test. Now the FlyLab is going to default it to sex. That is not the trait we're interested in. So we want to change it to body color first and foremost. And it's neat because it'll tell you how many you observed of each type and the total. Sorry, that's not supposed to be there. Now, what you have to do is fill in the expected. So how would we figure out how many flies we would expect of a black body type and how many flies would we expect of a wild body type? Well, you can use a Punnett square. So I've got one pulled up for you right over here. Maybe. Where did my scroll bar go? Here we go. Okay. So if large B stands for the wild type body, like the brownish one, and little b stands for black body, our Punnett square would look like this. So we would have 1, 2, 3 out of the 4 with a wild type body, and 1/4 with a black body. Now, as we go through, we're not going to want you to do Punnett squares for every single one of these, but since it's the beginning of the course, it's still okay to draw Punnett squares. So let's look at our FlyLab again. We got a total of 985 flies, and we would expect 1/4 of them to be black. So to figure out our expected amount of black flies, we take the total, and I'm going to multiply by 0.25 because that's the same thing as 1/4. You can do the math however you want, just decimal fraction, whatever. Just make sure you've got your percentages right. And that would give us 246.25. Well, I don't want 1/4 of a fly, so I'm going to round down. Cool. Now, to figure out how many wild types we have, again, we're going to start with 985. And we know from our Punnett square that about 75% of our flies should be wild type. So 738 and 75 hundredths, let's round up, 739. All right, cool. One thing you want to do when you're doing these calculations, do not times it by 1,000. Don't do this. A lot of people like to do 1,000 because that's how many progeny you set for when you were mating. You'll get the wrong answer every time. So, word of warning, don't do that. Now, you'll notice that the FlyLab basically does the rest of the work for you, right? The observed minus the expected here is 5. Then they square that and give you 25. And then they do this column, the 25, divided by the expected, 246, and you get 1/10. Does the same thing down here for the wild type. So now this is the total, right? This 13 hundredths is just 1/10 plus 3 hundredths added up. Now this is your chi-squared value, okay? This is a very important number. Now, The next part is to use our reference table to figure out if we reject our hypothesis or fail to reject our hypothesis. And I'll explain that a little more in a moment. But what we want to do is we want to remember that our chi-square value is 0.13, 1300ths. So we're going to open this up. And you'll notice on this side we have whole numbers. This is the degrees of freedom. These up here are the p-values. Now, whenever you're doing a statistical test, usually 0.05 is the cutoff for your p-value. So when you do these, you're going to be looking at this column. But you have to figure out how many degrees of freedom you have. Degrees of freedom is just your number of categories minus 1. So we have 2 categories, black and wild, 2 minus 1, just 1 degree of freedom. So here we go. So we're going to match up the 1 and the 0.05. And when we do, we get 3.841. Okay, awesome. So if our chi-squared value is less than our table value, we fail to reject the hypothesis. The hypothesis is, of course, being that body color is a Mendelian trait, right? Because that's what we predicted. We based our expected values on our Punnett square using simple Mendelian inheritance. So if our chi-square value is less than this, we fail to reject our hypothesis. And our chi-square value is much less than this. Our chi-square value is only 0.13. This is 0.38. So we would go and we would fail to reject the hypothesis. As a little aside, the vernacular, we wouldn't ever say we accept the hypothesis. All science comes with a level of uncertainty. So especially when you're doing statistical tests, you have 2 choices. You can reject the hypothesis, which wouldn't be appropriate given our calculations, but just in case you get to that, you could say, no, this is not what's happening. Or you can fail to reject it, and we say, we think this is what's happening. So hopefully that's a nice, easy peasy, relatively clear way to do chi-square. I hope it helped you, and I look forward to seeing you guys in lab.